Transmission Control Protocol, Internet Protocol. So let's start. What is TCP/IP? TCP/IP stands for Transmission Control Protocol, Internet Protocol, and is a suite of communication protocols used to interconnect network devices on the internet. TCP/IP is also used as a communication protocol in a private computer network, an intranet or extranet network. The entire IP suite, a set of rules and procedures, is commonly referred to as TCP/IP. TCP and IP are two main protocols, though others are included in the suite. The TCP/IP protocol suite functions as an abstraction layer between internet applications and the routing and switching fabric. TCP/IP specifies how data is exchanged over the internet by providing end-to-end communication that identify how it should be broken into packets, addressed, transmitted, routed, and received at the destination. TCP/IP requires little central management and is designed to make networks reliable with the ability to recover automatically from the failure of any device on the network. The two main protocols in the IP suite serve specific functions. TCP defines how applications can create channels of communication across a network. It also manages how a message is assembled into smaller packets before they are then transmitted over the internet and reassembled in the right order at the destination address. So here is the TCP/IP model, protocols and services, and OSI model. So layers of TCP/IP model are application, transport, network interface. Protocols and services are HTTP, FTTP, Telnet, NTP, DHCP, ping. And the transport, it is TCP and UDP. And the network, it's IP, ARP, ICMP, IGMP. And in the network interface, it is the Ethernet connection. And if we come to the OSI model, we have 7 layers, which is application, presentation, session, which includes all these here: HTTP, FTTP, Telnet, NTP, DHCP, ping. Transport and network are the layers. So in transport, we have TCP, UDP. In network, we have IP, ARP, ICMP, IGMP. Data link and physical layer is the Ethernet connections. So moving to the next slide, wherein we continue with the definition of TCP/IP. So IP defines how to address a route each packet to make sure it reaches the right destination. Each gateway computer on the network checks this IP address to determine where to forward the message. A subnet mask tells a computer or other network device what portion of the IP address is used to represent the network and what part is used to represent hosts or other computers on the network. Network address translation, that is called NAT, is the virtualization of the IP addresses. NAT helps improve security and decrease the number of IP addresses an organization needs. Common TCP/IP protocols include the following: Hypertext Transfer Protocol, that is HTTP, which handles the communication between a web server and a web browser. HTTP Secure handles secure communication between a web server and a web browser, which is also called HTTPS. File Transfer Protocol handles transmission of files between computers. Now, how does TCP/IP work? TCP/IP uses the client-server model of communication in which a user or machine, which is a client, is provided a service like sending a web page by another computer or server in the network. Collectively, the TCP/IP suite of protocols is classified as stateless, which means each client request is considered new because it is unrelated to previous requests. Being stateless frees up network paths so they can be used continuously. The transport layer itself, however, is stateful. It transmits a single message and its connection remains in place until all the packets in a message have been received and reassembled at the destination. The TCP/IP model differs slightly from the 7-layer Open System Interconnections, that is called OSI, networking model designed after it. The OSI references model define how application can communicate over a network. TCP/IP important. So let's see. TCP/IP is a non-proprietary and as a result is not controlled by any single company. Therefore, the IP suite can be modified easily. It is compatible with all operating systems OSs. So it can communicate with any other system. The IP suite is also compatible with all system of computer hardware and networks. TCP/IP is highly scalable and as a routable protocol can determine the most efficient path through the network. It is widely used in current internet architecture. The 4 layers of TCP/IP model. TCP/IP functionality is divided into 4 layers, each of which includes specific protocols. The first one is the application layer, provides application with standardized data exchange. Its protocols include HTTP, FTP, Post Office Protocol 3, Simple Mail Transfer Protocol, and Simple Network Management Protocol. At the application layer, the payload is the actual application data. The transport layer is responsible for maintaining end-to-end communication across the network. TCP handles communications between hosts and provides flow control, multiplexing, and reliability. The transport protocol include TCP and User Datagram Protocol called UDP, which is sometimes used instead of TCP for spatial purposes. The network layer is also called the internet layer, deals with packets and connects independent networks to transport the packets across network boundaries. The network layer protocol are IP and Internet Control Message Protocol, which is used for error reporting. The physical layer, also known as the network interface layer or data link layer, consists of protocols that operate only a link. The network component that interconnects nodes or hosts in the network. The protocol is the lowest layer include Ethernet or local area network and address resolution protocol. So in this slide we see the OSI model versus the TCP/IP model. So how does the OSI model has 7 layers into it, and how we have 4 layers of TCP/IP model. So we can see there are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer in OSI model. However, under TCP/IP model, we can see that we have a network access layer, internet layer, transport layer, application layer. And in the previous slide, we have seen already like what all protocols are there inside these layers. So let's continue to the next slide. And here we have uses of TCP/IP. So let's see. TCP/IP can be used to provide a remote login over the network for interactive file transfer, to deliver email, to deliver web pages over the network, and to remotely access a server host file system. So most of us are already using this in our day-to-day life. And most broadly it is used to represent how information changes form as it travels over a network from the concrete physical layer to the abstract application layer. It details the basic protocols or method of communication at each layer as information passes through. So let's talk on the pros and cons of TCP/IP. Let's start with the advantages of using the TCP/IP model, and it helps to establish a connection between different types of computer, works independently of the OS, supports many routing protocols. It uses a client server architecture that is highly scalable. It can be operated independently. It supports several routing protocols and is lightweight and doesn't place unnecessarily strain on a network or a computer. Ahead, let's see the disadvantages of TCP/IP. Is complicated to set up and manage actually, and it's a transport layer does not guarantee delivery of packets. It is not easy to replace protocols in TCP/IP. It does not clearly separate the concept of services, interfaces, and protocols, so it is not suitable for describing new technologies in new networks, and is especially vulnerable to a synchronization attack, which is a type of denial of service attack in which a bad actor uses TCP/IP. How are TCP, IP, and IP different? There are numerous differences between TCP and IP. For example, IP is a low-level internet protocol that facilitates data communications over the network. Its purpose is to deliver packets of data that consists of a header, which contains routing information such as source and destination of the data and data payload itself. IP is limited by amount of data that it can send. The maximum size of a simple IP data, which contains both the header and the data, is between 20 and 24 bytes long. This means that a longer string of data must be broken into multiple data packets that must be independently sent and then reorganized into the correct order after they are sent. Since IP is strictly a data send and receive protocol, there is no built-in checking that verifies whether the data packets sent are actually received. So it does not do a verification. In contrast to IP, TCP/IP is a higher level smart communications protocol that can do more things. TCP/IP still uses IP as means of transport of data packets, but it also connects computers, applications, web pages, and web servers. TCP understands holistically the entire stream of data that these assets require in order to operate, and it makes sure the entire volume of data needed is sent the first time. TCP also runs checks that ensure the data is delivered. As it does its work, TCP can also control the size and flow rate of data. It ensures that networks are free of any congestion that could block the receipt of data. An example is an application that wants to send a large amount of data over the internet. If the application only used IP, the data would have been broken into multiple IP packets. This would require multiple requests to send and receive data, since IP requests are issued per packet. With TCP, only a single request to send an entire data stream is needed. TCP handles the rest. Unlike IP, TCP can detect problems that arise in IP and request retransmission of any data packets that were lost. TCP can also reorganize packets so they get transmitted in proper order, and it can minimize network congestion. TCP/IP makes data transfer over the internet easier. TCP/IP model versus OSI model. So TCP/IP and OSI are the most widely used communication networking protocols. The main difference is that OSI is a conceptual model that is not practically used for communication. Rather, it defines how applications can communicate over a network. TCP/IP, on the other hand, is widely used to establish links and network interactions. The TCP/IP protocols lay out standards on which the internet was created, while the OSI model provides guidelines on how communication has to be done. Therefore, TCP/IP is a more practical model. The TCP/IP and OSI models have similarities and differences. The main similarity is the way they are constructed, as both use layers. Although TCP/IP consists of just 4 layers, while the OSI model consists of following 7 layers. As we already seen in previous slides, Layer 7, the application layers, which enables the user, software or human to interact with the application or network when the user wants to read messages, transfer files, or engage the other network related activities. Layer 6, which is the presentation layer, it translates or formats data for the application layer based on semantics of syntax that the app accepts. Layer 5, the session layer, sets up coordinates and terminates conversation between the apps. Layer 4, the transport layer, it handles transferring data across a network and providing error checking mechanism and data flow controls. Layer 3, the network layer, moves data into and through other networks. Talking about layer 2, the data link layer, it handles problems that occurs as a result of bit transmission errors. And the very first layer, which is layer 1, the physical layer, it transports the data using electrical, mechanical or procedural interfaces. How are TCP, IP and IP different? The functions performed in each model are also similar because each uses a network layer and transport layer to operate. The TCP, IP and OSI models are each mostly used to transport data packets. Although they will do so by different means and by different paths, they will still reach their destination. The similarities between the TCP IP model and OSI model include the following. They are both logical models, they define network standards, they divide the network communication process in layers, they provide framework for creating and implementing networking standards and devices, they enable one manufacturer to make devices and network components that can coexist and work with the devices and components made by other manufacturers. And here are the differences between the TCP/IP model and OSI model. TCP/IP uses just one layer application to define the functionality of the upper layers, while OSI uses three layers: application, presentation, and session. TCP/IP uses one layer physical to define the functionalities of the bottom layers, while OSI uses two layers, that is physical and data link. The TCP/IP header size is 20 bytes, while OSI header is 5 bytes. The TCP/IP is a protocol-oriented standard, whereas OSI is a generic model based on the functionalities of each layer. TCP/IP follows a horizontal approach, while OSI follows a vertical approach. In TCP/IP, the protocols were developed first and then the model was developed. In OSI, the model was developed first and then the protocols in each layer were developed. TCP/IP helps establish a connection between different types of computers, whereas OSI helps standardize routers, switches, motherboards, and other hardware. So that was it in the lesson of TCP/IP. I hope I have covered everything. If you have something to share or some additional topics that you want to add in up out here, you can comment in the comment section. Do give us a like for this video if you liked it. And thanks for watching this video. Please subscribe to support. Thanks.